today we're going to talk about invisible forces, and what we're thinking about is forces that can affect things without touching them. And I've got an example right back here. I got this little levitator going on, and this was something I got back, oh gosh, in the last century, I think I can say that. And there's a little magnet up here that's controlled, and there's a little sphere underneath, and you can see if I gently touch it, it's going to wobble back and forth. It's actually floating underneath there, and it's being held in place by a magnetic field. Oops. Well, it was being held in place by a magnetic field. Let's see if we can get this back here. There we go. Now it's being held in place by a magnetic field from the top that is holding a piece of steel in here. And that field is creating an invisible force down here. And we're going to focus on the fields today. And the question is, we're going to ask some questions about it, like, can the fields go through things? Here I have a copy of, let's see, Dancing in the Streets by Martha and the Vandells, a classic 45. Can a magnetic field go through a classic 45 record of Dancing in the Streets by Martha and the Vandells? And the answer is yes, it can. It goes straight on through. It's undiminished. And that's one of the interesting properties of magnetic fields. But we're going to explore a lot more interesting properties of fields today. And to show our next property of fields, we're over to Maud. And Maud, what do you got?
Well, I've got just like this big old green block magnet here, and I'm just going to set that on the table. And what I'm going to be exploring here is a magnetic field, and the I believe the technical term is the pointiness.
Oh, no, I think it's the liney-uppiness.
The liney-uppiness, yes, the
liney-uppiness
of the fields. And so I've just got a bunch of like little push pins here.
And those push pins are just standing up. It's like they're dancing. They're dancing in the streets is what they're doing.
They look like
and they're
trees.
just liney-uppy.
And they're liney-uppy. And they're all lining up. Oh, that one on the edge wants to lie down.
Yeah.
Maybe that was just having a kind of one of those days. So they're all lining
up. I
up.
can't blame them. It's about that year, you know?
It's getting there.
Something that also does this is like paper clips.
Oh my gosh, that's a little bunny paper clip.
Oh yeah. And so you can see that all of the push pins are kind of pointing outwards, and they're following field lines. They're following the magnetic field. What's interesting is that I can even take them a little bit farther away from the magnet, and it'll still do the same thing. So if I start with a push pin all the way up here,
standing up,
and move it around slowly, you can see it is following those fields. And that happens a lot too with paper clips. Make it a little bit more obvious here. I've got a little kitty cat and a little fish.
The cat is...
The cat, you know, the cat doesn't want to be... The cat just wants to be nosed down. And
cat's going to do what cat's going to do, I think. That's kind of the way cats, isn't it?
Acrobatic.
It makes more sense, though, because it wants... There are more vertical lines going this way, so it wants to be that way. It doesn't want to be horizontal, because that's not liney-uppy enough.
Awesome, awesome. And so that magnetic field is making an invisible force in all those things. And I can visualize those lines of magnetic fields as if I can almost see them. But wait a minute, we can show them another way. And I think this is a classic that Brenna is going to show us.
Yes, we can.
Brenna, what do you got over there?
Here I have a little bar magnet. I've marked the poles with red and blue tape, but I can show y'all the field lines just using a paper plate, sat on some blocks. If I put the magnet underneath the plate and the blocks, the magnetic field is still going to be transferred up to the plate as Maud showed us. So I can take some iron filings, which are going to line up with the magnetic field, and show y'all the lines.
Wow.
So you can see there's lines that go like this, and there's lines that go out, and then on the poles right here, there are some sticky uppy bits, like Maud was talking about.
Awesome. And all those iron filings have lined up with the field. So we're seeing those invisible lines of force right there.
Yes, and you can see how the field changes depending on where I move the plate.
Ooh.
So if I move the plate around, you can see these filings start to accumulate in different ways depending on how strong or weak the field is at their location.
Oh, that is awesome. And this is something anybody could try.
Yes.
Absolutely.
Yes.
Just some iron filings and a big magnet. And we're good to go.
Yep.
Now, one of the things we looked at the start was we had this magnetic field that was levitating that globe, and I saw it could not be blocked by a record, but we're going to look and see if we can block magnetic fields. And Maud has something awesome to show us and do a little demonstration.
Oh, yeah. So here I've got just a good old piece of flat, like refrigerator magnet here. And what I'm going to do is, so I have some magnet view paper, which is pretty cool. And so if I lay it on top of the magnet, there's nothing there quite yet, but you can kind of see a little bit.
It's pretty plain. So I'm thinking there's
pretty
no
plain.
magnetic fields. That thing's just not magnetized right now.
Yeah. And so that's what I've got this little magnet here for. I'm going to write my name with a magnet.
How are you going to spell it, Mod?
The correct way.
Everybody
Thank you very
wants
much.
to know, especially
I'm going to
Evan.
flip it around so people can read it, and then I'm going to put this magnet view paper over it, and there we go.
Oh, and there's your name.
Awesome.
And you
my
wrote
name.
your name with magnetic fields. Awesome.
And you know what, Brian? I took your challenge
All right.
to heart, and we're going to try to block it. I'm going to try first with just a plain sheet of paper.
And will that block the fields?
Not
Ooh.
quite. Looks like I need to try a little harder. So I
Denied.
got a piece of plastic here. It's like laminating paper plastic. And that's still not working. But you know what? I don't give up. So I've got this giant piece of steel here. Just good old thing. And it's right under there. And if I put the magnet view paper over it, there we go.
You can't see it then.
All plain.
That's all.
Nothing there.
Wow.
So steel, magnetic metal will do it for you,
Wow.
but nothing else.
That is awesome. So blocking it in steel, and steel's a magnetic material, so I guess that kind of makes some sense. That is awesome. And now we're going to use magnetic fields and magnetic forces to do something awesome. I think Brenna's got a little launcher over there.
Yes, I do. So we made this launcher just out of a ruler, and then there's some chunks of magnetic metal in between each of these sets of little magnetic balls. And you can see that right now there are 2 balls per little metal block, right? But they don't want to be there. Each of them wants their own metal block. So this one wants to go to there, this one wants to go there, etc., etc. So I can take this
Greedy.
horrible little thing, and I can use this magnetic tension that we have created to launch him off this block. So if I pull
And this
back,
happens real fast.
Yes,
So
if
better
I-
give us a countdown so we can watch this.
alrighty. Why don't you do the countdown, Brian?
All right. 5,
Brett, I forgot how to
4,
count.
3, 2, 1.
Oh, and he is gone.
And we had a
Gone.
awesome work on the magnetic marble launcher. I think you separated those little things and stored some energy in that field, which is kind of an awesome
That
thing.
I did.
So we're using magnets to make things move, and I think Mod has something where you can use magnets to make things move. This is like the world's simplest motor, I think, over
Oh,
here.
yeah. So it's called a homopolar motor. So what I've got is just a little battery, just a AA, I believe. Little AA battery, and I've got a neodymium magnet, and this one's just a little flat one. Flat circle. Sure. I know
Yeah.
shapes for sure.
It's a circle.
Hey, we know physics, not shapes.
And I've got some
Oh, it's a
plain
heart.
exposed.
It's so sweet. It's because we love the Little Shop of Physics Live people.
Yeah, I've got a little plain exposed copper wire, and I'm going to place it so that the tip of the heart, ooh, that was sparky. That was a lot of fun.
Oh, look at it. And it's rotating.
Yay!
Whee!
Spinny.
It's a little spinny heart. That is awesome.
One shape was not enough for me
Oh,
because
gosh, no.
this is
No,
Little
no.
Shop. So I saw this on our Little Shop open house. One of our friends had made a cylindrical, like a little swirly one, so I wanted to try that myself.
Oh my
and
gosh. That's just a piece of bare copper wire,
Mhm.
a magnet, and a battery. And you made a motor, and that thing is spinning.
It's going.
Wow, and the
For sure.
And that battery is making a current go through the copper, and then that magnetic field makes a force on the current. I think you've just made a connection between magnetism and electricity, which is a perfect jumping off point for the next thing that we've got over here on Brenna's side of the table.
Yes, so it turns out that magnetism and electricity are like this. They are directly related. So if I have an alternating magnetic field, I can induce an electric current. Okay? So basically what I have here is this salad spinner, and glued around the salad spinner are these magnets. Okay? And these magnets are going to spin around, and I'm going to expose this coil of wire hooked to a light bulb, and there's just iron filings inside, to this alternating magnetic field, and it is going to turn on this light. So if I press this right here, I can,
Whoa!
and look at that.
You just generated some electricity. And it was the magnetic field that generated the electricity, because that magnetic field goes right through the plastic of the salad spinner.
Yep.
And they get a changing magnetic field inside the coil. Makes a little
Inducing
electric current.
Turning on the light bulb.
Turn on the light bulb. And that's how electricity, like the electricity that people use, that's how it's generated, unless it's from solar cells. That's a whole other thing. But if it's generated from wind power, you're turning the turbine blades. And when you do that, you're changing a magnetic field, and you're using that to induce some current. And Mod has another thing that uses magnetic fields and electricity, and you've got some copper and some aluminum. Those aren't magnetic materials, Mod.
Yeah, well, you know, nothing is ever simple in Little Shop of Physics, my friend. So I've just got like this little, what do I call it, like a track, if you will, and I've got a little steel ball, and if I take it here, oh dear, forgot to block the end, but it's okay.
Pretty rolly. It's kind of rolling back and forth.
Pretty quickly. But if I go ahead and I change the material of my sphere.
Whoa. And give that a good tip. I want to see that thing roll. See if you can make it roll faster. Look at that. That's slow. That is rolling breathtakingly slowly.
Oh, yeah.
And what's different about that sphere?
It is, oops. It is, so the other one was made of steel, and if you would remind me what that one's made of.
Oh, it's just a magnet.
Oh, it's just a magnet, that's right.
A real strong magnet. Awesome, awesome, awesome. Did you pinch yourself with that magnet?
Yeah, a little bit, but it's fine. We'll live. It's just
Mod is willing to take one for the team here. Good spirit there. Oh my gosh, and then you got a copper plate.
Oh yeah, and then here I've just got like a little wooden dowel sphere looking thing, or not a sphere, a wooden cylinder that rolls right off of the thing, just to show you that.
Whoa, and that's pretty rolly.
Yeah. But if I take this little magnet and I put it on the copper, zoop.
Oh my gosh, it rolls real slow.
It's basically the same thing. And what's cool about this is that if I try to roll it kind of towards an edge,
oh, it turns.
It turns away from it.
Whoa!
It does not want to go off the edge.
It does not want to go off the edge, which I totally support 100%. That is fantastic.
Oh, yeah.
And this is because like the copper and the aluminum are really good electrical conductors, and you're making a connection between that like rolling magnet makes some electricity flow inside those metals, and then I'm getting forces on that current. So it's again another connection between the magnetism and the electricity. But wait, there's more.
Yes, there is. There's always more,
in Little Shop of Physics.
There's always more. So this is a solenoid that we got at a garage sale. And a solenoid is just a lot of wire wrapped around a spool, right? And I have connected it to a power source. I would not recommend doing this at home because it could go very wrong if you don't know what you're doing. But then I have this wad of nails, and these nails are conducting, and if I put them...
Oh, and you know what's... They're magnetic.
Yes. Conducting and magnetic. If I put them through the center of the solenoid, I can induce a magnetic field in them.
Is that just a little aluminum ring there?
Yes, it is. So if I plug this in, and I have it on a ground fault interrupter, just because, to be very safe, if I turn this on...
Whoa!
A little ring shoots
that
off.
Thing? Whoa!
Because I've induced a magnetic current, or magnetic field in those nails.
Oh my gosh, so the magnetic field, and it makes a current in that copper, and then the magnetic field, those invisible lines of force, make a force on that little ring.
They sure do.
Can we launch that one more time? I want to see that. I want to see that thing launch.
I love this thing, so no worries at all.
Kind of my favorite.
All right, is everybody ready?
We're ready.
Okay.
Oh, and we're launching. Awesome. And that was really easy to see how you put that together for sure. Now, Mod's got a device built out of these solenoids, and we really did get these. This was kind of like a garage sale find. It's kind of a crazy thing. Big coil of wire.
Oh, yeah, and I've got two, so I did one up Brenna here a little bit, sorry. But here I've just got a little button that will induce the current through both of these, and these are both solenoids, and so think what I'm going to do first is I will have one come out. I'm just going to take this chain and put it at the bottom of the hole here, and then should probably go the other way. And then I will.
All right, so we have a chain at the bottom of the solenoid, and you turn it on. Whoa, that yanked it right up through. Whoa, and then, wow. So that magnetic field yanks the stuff into the solenoid. Wow.
Right up there. And I can also go the other direction in this one here down at the bottom, and I will shoot the chain right at you.
Whoa. And that yanks it in pretty good. And the other thing to notice about this mod, if you leave that in there for a while, does it get warm? Does the chain get warm?
Yeah. Oh, yeah, for sure.
And so we're heating up the chain.
Leaving them there for a little bit, even that much, it's a little toasty here
And you can
at the
make
end.
stoves that work that way, actually, which is kind of an amazing thing. Awesome, awesome. And now over to Brenna, and Brenna has got this. This was a surplus thing from a local television outfit.
Yeah, so this is it's a big heavy box, and basically what it does, it has an alternating magnetic field that can erase CDs, your phone.
Not CDs, it'll erase magnetic tapes.
Oh,
back in the day when
okay.
we stored information with magnetism.
Yeah, there we go.
Oh yeah, parents, if there's any parents, you remember cassette tapes and VHS tapes. Oh yeah.
But I can see the alternating magnetic field by just putting a magnet on the outer edge of this because it's very strong. And if I put it on there and I turn this on, whoop, it starts to dance.
Oh my gosh, look at that thing dance. And again, that magnetic field is coming out of there and it's flipping one way and another, and it's making the magnet flip one way and another.
It's dancing.
It's dancing. It's dancing in the streets.
Yes, it is. And if I put it in the middle, it just shoots right off of there.
Right off.
But we know that if we have an alternating magnetic field, we can generate electricity. So here I have another solenoid. It's hooked to an LED or a diode.
Whoa.
You can see it lights up, and we want to know if we can block this magnetic field. So if I put this sheet of holographic plexiglass in between, turn it on, it does not.
Be nice. That field went right on through the plastic.
Yep. And if you have one of these or access to one of these, definitely don't put anything that you want to keep. Brian convinced me to put a light bulb on there earlier. I blew it out, and then I had to recreate the whole thing.
Yeah, you got to be a little bit careful with that device. So that's one type of invisible force. It's from magnetism. But we looked at other things that make fields and make these invisible forces, and one of them that is present all the time is gravity. The Earth makes a gravitational field, and it exerts forces on us. But if you drop something, it's as if you've turned off gravity. And we're going to show you a video of one really surprising thing. And here's one where we took a candle and dropped it. When you drop it, it's like you turn off gravity, and it's not the wind that's blowing out the candle. It's the absence of convection. There's no convection. You can't light a candle on the space station. Well, you probably wouldn't anyway because of the fire danger. But when there's no gravity, you don't get this motion of air, of heated air that keeps the candle flame going, and the candle flame snuffs right out. And so the presence of the gravitational field is really important for our lives. It holds us to the Earth, and it's also responsible for letting candles burn, which is kind of amazing. And Casey's got a little device here. I see now, it's not Mod, it's Casey now.
Surprise,
Wow, we
back
switched,
again.
mixed things up. Casey's got a
too.
little device for visualizing the magnetic field.
I do, yeah. So I've just attached some beads to some cardboard here just to give a simple demonstration. You can see when I hold the board this way, they're all hanging in the same direction. Can turn the board. They all still hang down. Can turn them this way. They're all pointing the same direction.
And this is the same thing that Mod did with the paper clips.
It is.
They're just lining up with the field.
Right.
It's just that the gravitational field, we're really used to it. And it's really a big part of our lives. And which way does it point? Oh yeah, you know.
Down.
Pointing down, pointing down. All right, and that's enough of gravity. Because we did a show on gravity before, and we will have more to say about gravity for sure. And next we're going to move on to talk about electricity. We're going to do some things with static electricity and forces. And this is another way to make some invisible forces. So if I take this pom-pom, and this is just a dollar store pom-pom, and I'm just rubbing my hand on it, I make some static charges on it. And you can see these little bits of the pom-pom are decidedly attracted to my hand and repelled from each other. And they're doing that because of the electric field. When I have some static electricity, I make this field that kind of like goes through space. And actually, that electric field makes these things stand up like this, but it does other things too. Casey and Emma went to City Park Playground and did a little video, and here's something that you might have noticed previously. Oh yeah, when you go down a slide, you're basically rubbing your clothes against the plastic slide. You get a lot of static electricity, and those resulting electric fields make your hair stand up. Make your hair stand up like crazy. And check out Emma's hair. Oh yeah, a lot of hair standing up there, and that is due to the invisible forces from those electric fields. Now that's one way that you can see electric fields in motion. That's one you may have seen. But we have another way of showing it. We had a little demonstration that we brought into the shop, and we put really, really big electric charges in a container of oil with a little bit of flock, which is basically fuzz. And the little fibers will line up with the electric field just like iron filings line up with the magnetic field. Whoa, look at them line up.
That's cool.
And that is a visualization of the electric field, just like the iron filings that Brenna used were a visualization of the magnetic fields. Oh my gosh, and look at them lining up with the points of the star. There it is. That's the electric field. And we have, of course, an alligator electrode because
Why not?
why not?
Wow.
Awesome. And so we're using that flock to visualize the electric field. But we're going to use the electric field to make some forces. And I think we're over to Casey. And Casey's got some cups and some cans. And show us what you got.
Oh yeah, quite a collection here. So I just have a plain old styrofoam cup here, and I have a scarf. This is my fabric of choice, but you can use really a lot of pieces, scraps of fabric if you have them. If you have gloves, you can use those. And what I'm going to do is I'm going to rub the cup on this scarf, and what this is doing is it's charging up the cup, which means it's just putting all these charges out on the outer edge of the cup.
Mm-hmm.
And if I take these different sticks I have here and I do the same thing and charge them up, and this definitely works better when it's dry out, so we'll see. This one should, it's kind of pushing it away. Let's see if this one works better. Oh, there we go. There we go.
Sure. That one attracts, and so one attracts and one repels. Let's see if we can get a good. There you go.
There we go.
The white one is
Bring it
pushing
back.
it away.
There we go.
The clear one is attracting it. And that's because they have different kinds of charge. One of them's positive and one of them's negative. And I think that PVC, the white one, is positive, and the acrylic one is negative. And I think the cup is positive. So if you take the cup and put it down, that's a positive charge. And then have that white plastic rod.
Let me get it charged
That's
again.
going to have an electric field around it, and that electric field is going to exert a force on the charges on the cup and make that cup roll away.
There you go.
Oh, yeah. And then the other one will attract it. But we've got a puzzle. We have a puzzle for kids, because the next thing we're going to do, you saw the white plastic rod attracts the cup. I'm sorry, repels the cup. The clear plastic rod attracts it. How about a can? Casey's going to put a can down. And first use the white plastic rod, and I'm going to poll folks. Do you think the can will be attracted or repelled by the white plastic rod? Will it attract or repel? Oof. And we're definitely seeing attract is way out in front. More than 68% of the people say attract. Let's give it a try. Let's see what happens.
All right, we got the white stick first.
White stick first,
Oh,
and
whoa!
it attracts like crazy. Rolls that thing, come back. It took it out of the frame. That was so attractive.
Go. Yep.
Awesome. Next up, how about if we have the clear plastic rod? And I'm going to launch the same poll. Different sign of charge. Different sign of charge. But we're going to be attracting a can. So the clear plastic rod, does it attract or does it repel? Ooh, man.
What are people thinking?
93% of people are saying repel.
Oh,
There's
geez.
a clear answer to this. People are saying repel. Casey, let's give it a shot. What happens?
Oh my gosh.
Nothing.
More charge. More charge.
Oh my gosh.
I'm going to nudge the can a little bit. So it might have to be on a sticky spot. There we go.
Oh,
Here
Attraction.
it goes.
Attraction. And so it
Back
attracts
the
as
other
well. And that's something to know about electric fields and conductors. Conductors are attracted by electric fields. It doesn't matter if it's from positive or negative. There's always an attraction here. Now, Brenna has a way we can do a little electrostatic levitation thing at home. Brenna, show us how this works.
So here I have a garbage bag that I've dissected. Actually, it's just a grocery bag, but I've cut out a little panel here. And I suggest that y'all do this at home because it's super awesome. But if I cut a little square shape out of this plastic bag, and I'm cutting out the, it says bread on it, so that's awesome. And then if I just, you can cut it into whatever shape you'd like.
And you're cutting into kind of an octopus shape, it looks like. It's
Yes,
like it's going to
I
have
am.
8 arms.
I think so, yes.
Is this the Electrostatic Octopus?
Yes, it is. It's the bread octopus.
Bread octopus.
All right, so now I have my floaty thing, right? But I need a way to make it float. So what I'm going to do is I'm going to do exactly what Casey did, except I'm going to do it with gloves instead of the scarf. And I can charge up any piece of plastic like Casey did. So here I have this horn, and if I charge it up and get it nice and staticky, it's going to have 1 charge, and if I rub my hands together on this sheet of plastic, it's going to have the exact same charge as the horn. And if I try and, it really wants to stick, right? Because it's opposite charge of my hand.
It wants to stick to your laptop, of course. And shake. Yeah,
Come
there
on.
you go.
Whoa,
There you go.
look at that.
Levitation.
Isn't that
it's like
awesome?
a levitating electrostatic octopus.
Oh, now it's on Patrick's camera.
It's on
It's
Patrick's
fine.
camera. I think we made our point, and
I
that
think
is
we
something
did too.
people can absolutely try at home. But we've tried to block magnetic fields. Could we block electric fields? And Casey's got a little demonstration for us. We got a cup. It's charged up, and you're going to put it next to that sheet of metal mesh, and then you have a rod that you're going to charge up and put it near that.
See if I can charge it up again.
Can we block the field?
Let's
Sound
see.
like Bob the
definitely
Builder.
repulsion.
Close.
But over there,
and
what? That metal mesh blocks the
Nothing.
electric field? We can make them stop?
no movement.
Oh my gosh,
Movement.
yes. So you can block electric fields
Nothing.
with a sheet of basically window screen. And Brenna has got a related demonstration over here, and I think you're going to block radio waves, and radio waves are waves of electric and magnetic fields.
Yes, they are. So we will talk about light waves and electromagnetic waves in a later episode because they're really, really awesome. But here I have a radio, and I'm going to turn it on, and I have it connected over there to a
a transmitter.
frequency thing to where, you know, we have only the best songs.
Awesome.
And if I just put it inside this cage,
Oh my gosh, it goes out.
it goes out.
It blocks that cage, just like Casey's thing blocked the electric field. This blocks the electromagnetic waves.
Yes, but if I touch it, I become the antenna. My body absorbs the radio waves,
Oh my gosh.
and thus we get a signal again.
And if you take your finger away, shut it down.
Take it
If you
out.
pull the radio out, awesome,
now it's
awesome.
gone.
And that's something people could try at home for sure. Now, Casey's got a device that makes electric fields as well over here. This is a little plasma ball, and this is from the, I don't know where we got this. But anyway, we get lots of these little plasma ball. You've seen these before.
Oh yeah, this is one of the things that if you've seen it, you put your fingers on it and it can make all of those little electric waves come over to you.
Yeah, you're changing the electric field, and actually the electric field looks like it's coming to you is what it looks like.
Casey, would it make it better if I shut the lights off?
That's maybe.
You think so, Brian?
Do it.
All
do
right.
It, all right.
Let me go over and
Casey.
shut the lights
Momentary
off.
pause.
But the electric field's going to your fingers, but it doesn't stop at the edge of the ball, does
It
it?
does not. You
Oh my
can
gosh.
See, oh, maybe you can see this better now.
Oh my gosh, look at it on your
Ooh.
hands. And if you bring a light bulb up next to it,
It lights it up.
what? The
this is
electric
just the-
field from the ball actually lights up the light bulb even though it's outside the ball.
It does. Yeah, this is just one of those regular bulbs that you have around your house somewhere, I'm sure. But I took all of these little neon bulbs. Can't really see it in the dark right now. I attached them to a metal sheet. And since those electric waves don't stop at the glass, you can see I don't have to be touching it for it
Whoa.
to light it up.
My gosh, they're lighting up even at a distance. That electric field is making invisible forces that go through the air and makes those things light up. That is an awesome, awesome thing. And Casey, I'm going to say, I don't know what we do to top lighting a light bulb through the air with some invisible forces from a plasma ball. I think that might be an awesome place to wrap up this installment of Little Shop of Physics Live. Next week, we're going to talk about forces and motion. We will see you folks back on Little Shop Live next week. Thanks very much.
Bye, everyone.
Bye-bye.